Okay, this is a lesson, the first lesson in organic chemistry, and this is just a layout of what's to be expected. Okay, so this is the first thing here you'll see is hydrocarbons on this flow chart. A hydrocarbon has carbon and hydrogens in it, so I'm going to put C comma H. And now the next thing here is divided up into aliphatics and aromatics. Aliphatics are just carbon chains. Okay, so let me just give you an example. So a carbon chain could be CH3 dash CH2 dash CH3. Okay, so that's an example. An aromatic has something called a benzene ring. And a benzene ring has the formula C6H6. Okay? And a benzene ring looks like this. It's basically a hexagon with 3 double bonds, like so. Okay? Now, back on the other, so as long as you have a benzene ring attached to a carbon chain somewhere, at least one benzene ring, it's an aromatic compound. Alright, the next two under aliphatics are cyclic and acyclic. Acyclic are chain carbons, straight chain carbons, so straight chain carbons. And cyclics are rings, right? They form rings of carbons. Okay, now under the acyclics, you have alkanes. Now you see that in blue, you'll see CnH2n plus 2. That is just the formula to tell you how many carbons there are, how many H's there are. Okay. So let me give you the formula for an alkene. An alkene is a C double bond C, and it has the formula CnH2n. So it's just double the amount of N's. And an alkyne, it has at least one triple bond in the chain, and it has a formula CnH2n minus 2. Okay. And you could see that it's just 2n plus 2, 2n, and then 2n minus 2. Okay. Now, let's take a look at this list. You have to memorize this list. Now, depending on how many carbons there are in the chain, it corresponds with the name. So the first one is methane, ethane, propane, butane, pentane, and then 6 is just the name of hexane. It goes by the name of the shapes. 7 carbons is heptane. 8 carbons is a octane. Oops. 9 carbons is a nonane. And then the last one, 10 carbons, is called a decane. Alright, so that takes care of that. Alright, so under alkanes, the names, first of all, there's no methane. There's no methane. There's no there's no one carbon double bond. You need 2 carbons to have a double bond. So under the alkenes, we would have ethene. Then you would have propene. Notice that the ending, it just goes with the name. So see, the ending is ene. I'm just switching all the endings to ene. Under alkanes, it would be ane, so I'm just going to have ane. Okay. Now, so I'm not going to continue it, but I'll just do one more. Actually, I'll just do the last one there, which is, oops. All right, so last one here would be, I'll just do one more, butene. Okay, and so on. Under here, the next one here, you can't have one carbon with a triple bond. So next one would start with ethine, propine, and you could take a minute just to continue that list, right? I'm just going to highlight, notice the endings, go with alkynes. Okay, so just take a minute to fill that in. Now next I'm going to show you the formula. So let me just get my stuff ready. Alright, so if you'll notice, under alkanes, you'll see the formula CnH2n plus 2. So let's take a look at an alkane for F. Let's do propane. So it would be C3H, so 2n plus 2. So it's 2 times 3 plus 2, which gives me 8. Okay, that's for an alkane. For an alkene, it would be propene. And look at the formula, it's CnH2n. So it'd just be C3H6. That's for propene. And for an alkyne, if there was a triple bond in there, it'd be an alkyne, and it would be Cn, so C3, 2n minus 2. So it's 2 times 3 minus 2, which is 4. There you go. So that's how you would use each of these formulas, right, in order to write their chemical formula. You just have to know the names of the how many carbons there are, and then know the formula, right? So again, it's 2n plus 2, 2n, and then 2n minus 2 for the alkynes. All right, now let's get to a little more complicated. This has to do with branches. Okay, so you can pause at any time to take a note. I'm just going to continue on here. So a functional group is a small structural unit in an organic compound which most of the compound's chemical reactions occur. Okay, so I'll give you an example. Let me give you an example here of, let's say we're dealing with an alcohol. An alcohol has a functional group of OH. So if you see an OH attached to that carbon chain, that's an alcohol, right? And that alters its properties, and that OH has mainly to do with when it reacts, okay, which we'll get to later. All right, so let's get to naming alkanes here. Naming alkanes. So numbers with dashes before branches, branches in alphabetical order, and Greek prefixes for more than one of the same type of branch. Okay, so the first thing you do is you highlight the longest chain. So longest chain gives me how many carbons? 1, 2, 3, 4, 5, 6. It gives me 6 carbons. Now, I don't have to highlight it straight as long as it gives me 6 carbons. So I'll give you another example. I could highlight it like this. That still gives me 6. Okay? So it's the longest continuous chain. It does not matter if it's straight or not. Okay, so let's number it. So this would give me 1, 2, 3, 4, 5, 6. So you either number it from left to right or right to left, depending on what gives you the smallest combination of branches. Okay, so if I were to number it the other way, let's just show you. 1, oops. My branches would be on the 3, 4, and 5. If I numbered it in black from right to left, I would get the branches on the 2, 3, 4. So the 2, 3, 4 is obviously smaller than 3, 4, and 5, right? So the way in black is correct. The way I numbered it in black. Okay, so let's name it now. Okay, so If you look at the branches, I have a methyl and I have two ethyl groups. Okay, so two carbons is ethane, but because it's a branch, I'm going to name it. I'm going to change the ending to YL. Okay, so when it's a branch, branches are called alkyl groups. So they're called alkyl groups. Notice the ending, YL. So instead of saying ethane, I'm going to say ethyl. And you do it in alphabetical order. Okay, so it's the ethyl groups are in 3 and 4, so 3 comma 4. You put dashes between words and numbers, or letters and numbers. Now, because there are two ethyl groups, I'm going to say di. Now, notice this di does not contribute to alphabetical order. Okay, you're going by the name of the parent branch, so which is ethane, ethyl. So it's diethyl. So alphabetical order of branches, right? So ethyl comes before methyl alphabetically. So the next one here is the 5-methyl. And then hexane. There you go. And hexane is the parent branch. Alright, so let's number this one right here. So this would be 1, 2, and 3. Okay, so I'll get the branches on the 1 and the 3 no matter how I number it. Okay. So it's going to be 1, comma 3 dash dimethyl, because there are two methyls. And then this ring, so I'm going to put the word cyclo because it's a hexane. So it's a pentane. There's 5 carbons. Each point is a carbon. So if I numbered it fully, let's go back and number it. 3, 4, and 5. So it's each point is a carbon. So there are 5 carbons in that ring. Okay, so the parent chain is, so I'm going to use the word cyclo because it's a ring. Pentane. Pentane is 5 carbons. Okay, so that's how you number a ring. Alright, just here's some other branches. Now this is this example is a little different because it's a branch of a branch. Actually, no, it's not. So let's highlight the longest chain. The longest chain would be this. That would be the longest chain. Okay. Alright. It's the longest continuous chain. That gives me the most carbons. So if I were to number it, remember you have to number it going from giving it the lowest numbers possible. So I'd have to go 1, 2, 3, 4, 5, 6, 7. That would put the number. Oh, so it does actually this way. It doesn't matter how you number it, left to right or right to left, because you get the 4, the branch on the 4 carbon. So it's 4 dash ethyl heptane. All right. Now the next example here, if I highlight the longest chain, it would be this. Now let me number it. So this would be 1, 2, 3, 4, 5, 6, 7. So actually, the way I numbered it, it doesn't matter from left to right to left or left to right. You would still get the branch on the number 4. Now, if I number the branch, let's number the branch. This would be the 1. Okay, the branch, the carbon connected to the parent chain is number 1. So I can go either left or right. So 1, 2. Now notice I have a sub-branch. This thing right here is a sub-branch, right? It's not part of the main branch. It's connected to a branch. So it's a branch of a branch. The way you name it in this way is a special way. So I'm going to put 4. Okay, so you name where the main branch sticks out. So it's 4 dash. Now, because I have a branch of a branch situation, I'm going to use a bracket. And so I go sub-branch. So the sub-branch is on the number 1 of the main branch, right? So this thing right here is the main branch because it's long. It's the longest type of branch. The red sticking out is the subbranch. Okay, so you go subbranch, then main branch. Okay, so the subbranch is connected to the number 1 carbon of the main branch. So it's 1-methyl. The main branch is called an ethyl. I don't put a number for it because I already have the number 4 already. And then the main thing is heptane. The main parent chain is heptane. There you go. Okay. So subbranch, then main branch, and then you have your parent chain. Okay. Right. There is another way to name it. Okay. And this is using the old names. Okay. So let me label this. There's 2 types of propyl branches. Arm just means the main parent chain. Okay. When it says main chain, it's the parent chain. Okay. All right, so let's take a look. This one is a regular propyl branch. So we say N-propyl. Now we usually don't say N-propyl because we usually have a number where that N is. So we would say 3-propyl, okay, or 4-propyl, whatever it is. Now see here, the second one here, the main branch is connected to the the parent chain is connected right here to that main branch. So it's connected to the middle carbon. So it's not a regular branch. So see how it forms that like a letter capital T? That's called iso. Isopropyl. Okay. Next are the butyls. So this is called N-butyl. It's connected to the first carbon. That's how you normally would connect it. So it's N-butyl. The next one right here is connected to the second carbon. So this is called sec-butyl. Sometimes it's known as S-butyl. Okay, so you can say S-butyl or sec-butyl. See how you have in the next one, it's 4 carbons on the main branch, but you see that capital T. So that is called isobutyl. It's butyl instead of propyl because there are 4 carbons. And here you'll see like a cross. See that cross right here? Cross. That's called tert or tertiary butyl. It's called tert-butyl. Sometimes it's known as T-butyl. And sometimes this is known as I-butyl. Alright, or you could say isobutyl. So if I were to use the old way of naming it, let's go back and name this one. So if I erase all that stuff I did before, let me erase all this stuff here. Okay, this you could see, this group right here is called an isopropyl. So the other way of naming it would be 4-isopropyl heptane. So the isopropyl replaced the thing in the bracket. Okay, so that's the old traditional way of naming it. Okay. Let's go through some more other examples right here. Okay, so let's try this one. Now, the longest chain has to be going across like this. Okay. So let's name it. Let's number it, sorry. So you can number it from right to left or left to right. It's still on the 5. Okay. So let's name it the IUPAC way first. So this would be 1, 2, 3. So you have a sub-branch sticking out on the second carbon. So let's name it. So we would say the number of the main branch first. So it's 5 dash bracket 2 dash. The sub-branch is methyl connected to the second carbon on the main chain. The main chain is propyl. Remember, we don't have to put a number for it because we already did. It's the 5. And it's decane. 6, 7, 8, 9, 10. So decane is the parent chain. If we named it the old way, you could see the shape is a isobutyl. So it's 5 dash isobutyl decane. All right, let's take a look at this last example here. All right, so if I were to number it, 2, 3, 4, it's 4 either way. Highlight the longest chain. And this would be, so let's name it the old way, 1 and 2. So it'd be, if I were to name it, it would be 4 dash 1, 1 dimethyl. Those are the sub-branches. Ethyl. And then 6, 7, 5, 6, 7, heptane. There you go. All done. All right, last one here. All right, these are just how you would write it. First one is called condensed structural. Condensed structural is when you show the dashes between the carbons, but you put the H's with the C's. You condense the H's around each C. Okay. Now, how do you know how many H's to put? Well, carbon bonds 4 times. All right. So if you look at that first carbon right here, that is bonded once right there. And so you need 3 H's around it to make it have 4 bonds. Right, so it's just a matter of counting. That second carbon you see, it's CH2 because the carbon is bonded to 2 other C's. So you need, 2 more H's to make it have 4. So let's write the expanded form. Expanded form is just basically, I will condense it even more. Right, no bonds. And I'm going to put brackets for the branches, like that. There you go. Expanded form is just more condensed. Now you have linear form. Linear form is just each point is a carbon. So it's 1, 2, 3, 4, 5. So you do like a zigzag, each point is a carbon, so there are 5 carbons, and then there were 2 carbons connected to the middle. So let me do that. 1, 2. There you go. Alright, that concludes our lesson for today. Check your Google Classroom for your homework. Goodbye.